mention up here. Let's finish this up with percentiles. In your percentiles of your box and whisker, again we said it's like money. So quartile 1 is a quarter, 25%. Quartile 2, 50%. This is your median. That's the middle of your data. Quartile 3, 75%. So when you're doing this, you can figure out where your percentages are. But remember, percentile is not a score. It says how much better you did than somebody else. Now, if you take a look at example 5, example 5 has a couple of graphs. You need to look because I don't have the graphs. So example 5 has a couple of graphs for SAT scores. And notice along the y-axis, this is where they put the percentile. Not a score, but a percentile. And along the bottom, they put the scores. So one score of, say, 1,000, if you trace it up, it's about a 45 percentile. I'm on page 97. So if you're looking to see, like say if someone had a score of 1,000, find the 1,000, go all the way up, and come across, you're about the 45th percentile. This is how they rank SAT scores, because they don't really look at your individual, so they look to see where you're ranked in your class. And in a few minutes, we'll be able to find, well, not yet, but a little while soon, we'll be able to find the exact cutoff ones that they like to look for. These are things that are commonly used. Now, here's an ogive, a flexible ogive graph. It represents the cumulative distribution all the way up as they accumulate, because they want to take a look at how many have had each one of these scores. So they accumulate. So around the 1,000, you're at 45%. If you want to find the 60th percentile, come across 60, come across till you hit your line, and look down. That's the score that ranks the 60th percentile. The percentile rankings, a lot of times you get in your, when you were younger, your Terry Novus or whatever it is that you guys took that ranked you. And they came like this. They had lines that you were 46% higher, that you were 86% higher, and they broke it all down into like math computations, word problems, and all those kinds of things. And they figured out what percentile you were. It wasn't your score. It was how much better you did than everybody else. So if you're in the 64th percentile, that means you scored better than 64% of that group. That's what this means. So what was your score? You can find it by going to 64, come across, and find your score. That was your score that you scored, but you were better than 64%. So when you're doing this, your percentile just kind of gives you some kind of ranking for that. Now, this part is the basis of our course. Is our standard score. Up to now, you can take your standard deviation curve, and you can find the 1, the 2, the 3, the -1, -2, -3. Up to now, you can find just those standard deviations when we give you a mean, and we say the mean is 80, and the standard deviation is 5. For 80, 85, 90, 95, 75, 70, 65. You can only give me those. So we have a little formula that allows you to find any score anywhere on this curve. Now when we look at this curve, we can see your zeros in the middle, your negatives are to the left, your positives are to the right. So when we use this little formula, we need to say, where exactly does your score fall? That's where it's going to determine when you're negative, positive. That's what's going to help you figure out which way do I subtract these. So say, for instance, I have a score of 80. 80 is my score, and my mean is, let's make this 85. 85 is my score. My mean is 80. I'm going to use this formula. It's going to say, okay, x minus the mean. If my score is here, should my z-score come out positive or negative? Don't even worry about these yet. Should it come out above, positive, below, negative?
Yeah, your x.
If my x is 85.
Oh, positive.
Positive. So I'm to the right of the mean, right? So when I subtract my x, subtract my mean, and I divide by my standard deviation, I get a z-score of 5 divided by 5, or 1. I get a z-score of 1. And was it my z-score, my standard deviation 1, standard deviation above the mean? Standard deviations, we're going to call them as z-scores. It's still your standard deviation. So how does this help me? If I have a score of 88, and you really can't find 88 because it's not the middle, 87.5 would be your middle, 88 is a little bit past the middle. So I know it's somewhere between 1 and 2. It's above my mean, so it's positive, and it's somewhere between 1 and 2. So now, when I use this formula, the x minus the mean divided by the standard deviation, I get 8 over 5, or 1.6. I get a score of 1.6. And didn't we say it's a little bit higher than the 1.5? It's a little bit higher than the middle of that bar? No? Okay. So 1.5 was smack in the middle. And in Algebra 2, you could find the middle because they kind of sectioned it so we could find it. But now, I'm a little bit above the middle between 1.1 and 2. So that I'm a little bit above 1.5. There's my 1.6. Now, take a score below the mean. Let's find the score of 71. What would you estimate it to be close to? Negative 2. It's below the mean, so it's negative. It's close to negative 2. It's between negative 1 and negative 2. So let's use your formula. So if we take 71 minus your mean over your standard deviation, there's your negative number right there. Your mean is higher than the number we need. So this is going to come out negative. Negative 9 over 5 will give you negative 1.8. Good? Good.
I guess that would.
Okay, so now, here you are, negative 1.8. So now we should be able to see how much, what the percentages are below and above. Only we're not going to be able to use your chart for these percentages. We're not going to be able to use your curve. We're going to have to use a little chart to find this. So I want you to just realize that your score is negative, it falls to the left. If your score is 0, it's going to be in the middle. If your score is positive, it's going to be to the right. Now I'm going to give you a table. Actually, you have it in your books. If you turn in your book to the opening page this way, right on your binder, basically, the first page, it's called Table 4. They put this one first because this is the most used. This is your z-score table. This is where your percents come from. Your book doesn't have it? Okay. The back? It's in the back of the first page, Taylor?
It says standard normal distribution.
Yes, that's it. If you have a pullout, it's on the pullout. If you don't have it, go to the blue.
It's supposed to be a pullout.
Yeah, it's not a full.
No, it isn't. It is. It's perforated.
Yes.
But over the years, kids don't put it back.
Like,
So guys, if you would pay attention to key formula number 7, that's
Let me tell you what page to look on back here. If you go to the blue binder, guys, there's blue margins here. Go to the blue margin. It's page A16. A16, A17. That's not the one that rips out. There was a separate thing towards the back of the book that ripped out. That one.
Yes, sir. It starts at 2 with no chapter.
Right. This is your, so there's a number of ways you can find the table. If it's not in the beginning of your book, it'll be on A16, A17. They're blue binders. It'll be a pull-out in your book, or it could be in the first page of your book. I'll make a copy of this table and get it to you because this is something you're going to keep in your notebook and use all the time. Now, I want you to notice on this table, there's positives and negatives. There's positive z-scores, we're above the mean. There's negative z-scores, we're below the mean. Now, let's take our z-score of, negative 1.8 right here. Okay, now I can't really tell what percentage falls over here because it's this group and this, but then there's a little tiny bit of the other one. So we should be able to tell by your table. Guys, you need to pay attention. Is this going to be greater than 50% or less than 50%? Less than. Here's your 50% right here, right? So we're going to look up negative 1.80 in your table. Now, in your z-score column, you're going to see negative 1.8. And then you're going to see on the top 0.09, 0.08, 0.07, all the way down to 0.00. If we want 0.180, we come all the way down to this last column. Because if you add, God bless you, 1.8 plus 0.00, you get 1.80. It gives us the tenths. We have to find the hundredths position. Think money. These are the pennies up here. This is a dime. So when we add your money, this will be 1.89, 1.88, 1.87. It's just like money. You're going to get two positions of your decimal. So when you pull this out, tell me what that number is. Go to your chart, look at the negative 1.8, and come all the way across to the zero. Thank you. 0.0359. How do you take a decimal and make it into a percent?
Move the decimal over 2 places.
Good. So this represents 3.59%. Right in that little section. Because we couldn't figure that out because it didn't fall exactly where we wanted it to. Now, watch at the z-score of 0. Let's take the ones that you know. Take the z-score of 0. Find me 0 on your chart. You can find it either in your positives or your negatives. Now your positives on the top go from 0, 0, 1, 0, 2. That goes in order. Your negatives go the opposite way. So find me which area is when you have a 0 standard deviation, a 0 z-score. 0.500, right? What is 5.500 in degree? 50%. Isn't that 50% of our chart? So let's take a look at another one. Let's take a look at, here's the 0. This up to here is 50%, right? This in here was 32%. So let's pull off a standard deviation of 1. Find me a z-score of 1.00 and tell me what that area is going to be. Find your 1.00 and tell me what your area is. I think this is 34%.
Yeah, are we using the last question?
No, I'm just using my chart. 8, 4, 13. Did everybody get this off their chart?
Yeah.
Okay, so now flip this to a percent. 84.13%. And if this is 50%, and this little section that we knew from our graph was 34%, because the two were 68, right? So if this is 34, doesn't it make sense that it would be 84%? So your z-score table will tell you the exact value at what exact point that you want. Before, you can only do these. Now we're going to do everything in between. What this also gives you is a percentile. This says your percentile at the same time. Your percentile says this. If you had a score that gave you 1 standard deviation above your mean, you are better then 84% of the rest that took this. If you have a score up here, and we add, your area always comes from the left, from the lower to the higher, because this whole curve is 100%. This whole curve represents 100%. And we read this curve left to right. So we'll take a look at your curve, and we'll add your percentages from the left to the right. And as they add up, this is what gives you a percentile. When you also look at your chart, it always gives you the area to the left. This is important. So whenever we build a chart, we're going to look at the area to the left. It's kind of is another way to do your standard deviations when they don't fall on 1, 2, 3, and most of the time they won't fall on 1, 2, and 3. And this is, believe it or not, most of the work we do in this course revolves around your z-scores. Your z-scores for populations, your z-scores for sample sizes. Most of the time it falls through this. We'll find your z-scores that correspond to these things and work those out. So let's go to this one and find a z-score. The monthly utility bills in a city have a mean of 70 and a standard deviation of 8. So pull this information out. Right now it's a population and a standard deviation of 8. This represents your population mean. Now, if we make a chart, and I want you to make a sketch, when you do this, I want a sketch. So until we get used to where everything goes, and sometimes it takes a very long time to get used to where it is. Here's your mean, right here, 70. Here's 78, 86, 94. Then go the opposite way, 62, 54, 42. Right? No, 46. 46. So, keep your scores up there. Keep them on your chart. Everybody see what I'm doing? Take the mean, put it in the middle, do your standard deviations up and down. Now, when you're looking for a score of 60, are you okay? You need a drink of water?
Good.
You're good? Okay. If you need water, go ahead and get it. If we're looking for a score of 60, find it. So 60 would be somewhere over here, right? Estimate. What do you expect the standard deviation to be, the z-score? Negative 1.2. I expect it to be negative. I'm below the mean. I'm between negative 1 and negative 2. So Ben's going with negative 1.2. Estimate. So you know where you're going. So now, even if you forget which way to subtract, you need a negative, right? So the only way to get a negative is a smaller minus a larger. So take your smaller number, 60, and subtract your larger number, which is your mean. It's x minus the mean. But if you don't remember that one, place it on your chart and you'll know if it's to the left, you have to subtract so it's negative. And divide by 8. So now you're going to get 10, negative 10, divided by 8. And this is going to give you your z-score. Negative 1.25. Look how good Ben was. That was good, Ben. Now, let's see what percent falls to the left of negative 1.25. So go to your table, go to the negative side, go to negative 1.2, and come over until you see the 0.05. Because when we add negative 1.2 and 0.05, we get negative 1.25. So come down and tell me what that area is. Go to the negative.
Oh, negative.
It's okay. And so how did we know it was negative? Because it was, you gave me one greater than 50, right? Nope, go to negative 1.2. And what's the tenths positions that you need? You have 2. And what's the hundredths position? 5. Point. It can't be greater than 50.
0.1056.
Oh, I did pause.
I said that right. I ain't seen no
Oh,
negatives.
okay, so come to the chart. I'm not on here. I'm using this formula. X minus the mean over the standard deviation. And the way we figure this out is because it's negative, it's falling to the left. Okay? So tomorrow we're going to finish this section up and talk about how to compare.